In this video, we're going to be discussing event-driven architecture. Now, event-driven architectures have become very popular over the last few years, and I'm going to try to use examples to sort of deploy this to bring us home. Event-driven architectures are simply communicating through events, right? What is an event? An event can simply be a process that is making a payment for a tool. That's an event, right? A process can simply be um, payment completed. It can be order placed, right, in a commerce service. It can be the service has been received or fulfillment has been made. Now, the important thing about events is that in this context, right, it sort of enables the different components to work with one another. Now, to define event driven architecture, I would use this analogy using events. So rather than components calling each other directly, right, event driven architecture has producers that they emit what we call events. So things like order placed, things like payment received, and we also have consumers that react to these events, right? Now, this fundamental shift in terms of communication patterns creates something we call loosely coupled systems that can scale at a very beautiful level, right? Now, there are tools that we use for these. Now, events typically flow through things we call event buses or messaging queues. And these messages queue are like Apache Kafka. I'm sure you must have heard about Kafka, RabbitMQ, AWS SNS, or SQS. The truth is, when we talk about producers and consumers, producers don't know who the consumers are in an event driven architecture. They don't know who consumes their events, and the consumers don't know who produces the events. They only understand the event format, right? And this is why this decoupling is extraordinarily beautiful. So let's think about it this way: there is a messaging bus in the middle, and we have different decoupled systems all connected or all subscribed to this messaging bus. There is a producer and then there is a consumer. Both are subscribed to this messaging bus. So let's give an example. If, for example, we are an e-commerce platform and we want to give out rewards in Black Friday, or we're giving New Year rewards. Now, these New Year rewards, um they are for specific customers, and so with this we have conditions. These specific customers are customers that buy above $10,000 in a basket, and so whenever a user purchases a product, we check the amount, right? That is, the producer checks the amount and it sends it to the event boss. The event boss basically um, holds that information. The consumer looks at the information, right? Runs it through its conditions. That is, what are the conditions for giving that reward? So in this case, the consumer is the reward engine, and the producer is the order management tool. The consumer has looked at this. Does this fulfill the conditions? If it's yes, then it basically in turn gives that reward, right? If it's no, it does nothing about it, right? But the beauty about this is the producer or the consumer, they do not talk to each other directly. They don't even know each other. All they know is the messaging format. This information has been shared, they pick up the information and then they use it. That's all they know. And they're all connected to the central event bus. Now, there are a lot of advantages to this, and that's the beauty of asynchronous messaging, right? Number one is what we call asynchronous resilience. Since services interact through the event stream rather than direct calls or direct API calls within one another, one component can fail or maybe it's slow without bringing the others down with it, right? So those queues naturally handle the different back pressures of the load that is coming, or if there's a load spike. Another advantage is independent scaling, where each service scales based on its own event processing capacity. So if the inventory service is struggling, it can scale just that service without touching the other services, right? So it's based off of that pressure or that load that the inventory service is facing at the time. Also, extensibility. When you can add new functionalities, ju- it it often just means adding in a consumer to an existing event. Remember what an existing event is and what a consumer is, right? So there's no changes to existing services that will be required. But it is also important to consider the complexities when it comes to all of this. For event driven architecture, it's so beautiful, it's wonderful. It's really around just building beautiful systems that they don't need to leverage one another, but they can simply just asynchronously complete tasks together. One simple complexity for your consideration here is debugging event driven architectures or event driven systems can be very tricky because the flow is not linear, right? And when you are trying to ensure eventual consistency, it requires careful design, right? So events are simply immutable facts. If you remember, I said an event could be an order is placed or a payment is received. Those are immutable facts, right? About what has already happened. That's simply what an event is. So you must design event schemas thoughtfully to avoid breaking your consumers, right? It is really important because when you are debugging this, those events have already happened. So whatever use case that you see as a common pitfall there, it's important that you're able to design those event schemas thoughtfully and well enough so that you don't break your consumer flow and you don't sort of end up losing money in the process. Because again, in most cases, most often than not, you might start to lose funds in the entire process if it's not built well. Well, again, it's a beauty. There's a lot of good in it. But if used properly in the right context, it would give you the results that you